Right, in this video we're going to examine surds. We're going to use these definitions to show how we can simplify some surds. One thing to remember is the square root of a is never negative, right? So it's always greater than or equal to naught. And it's only meaningful if a is greater than or equal to naught, because you cannot square root a negative number in the real number system. Now we're going to use this identity where the square root of ab equals root a times root b, and the square root of a over b equals root a over b. So first example we're going to do is to simplify a couple of these. So we're going to simplify we're going to start with root 12 plus root 27. Now the key thing to this is to try and work out what square numbers are factors of these. Now the easiest way to do it is to do prime factorization. So we know that 12 is the same as 2 times 2 times 3. And we also know that root 27 is 3 times 3 times 3. Now every time you have a pair, okay, you have a square number, so you effectively can take that pair out. So what we're going to do is we're going to take this pair, we can square root it. We can take this pair and we can square root it. So the square root of 2 times 2 is 2. So we're going to use first of all this process here of splitting it up. So we've got the square root of 2 times 2 times the square root of 3 plus the square root of 3 times 3 times the square root of 3. So what we've done again, we've just taken the pairs out and made them separate. And that is the key to simplifying all of these. Do that each time, because effectively you've got 4, square root of 4 is 2, 9, square root of 9 is 3. So that gives you 2 lots of root 3, because that gives you this. And you got times root 3 plus, now this will go to 3 times the square root of 3. So just highlight that so we can see how things are changing. So this becomes 2 and this becomes 3. Now effectively we have a common factor. So we've got the square root of 3 and the square root of 3 here. So we've got root 3 times 3 and root 3 times 2. So we can take root 3 out as a factor, you might like to think, and you're effectively left just 2 plus 3 equals 5 root 3. So the blue bits have come together to add to give you this, and therefore to give you 5. So you can also think of it as 2 lots of root 3 plus 3 lots of root 3 gives you 2 plus 3 lots of root 3, which is 5 root 3, and you have your answer. Now in our next question we're going to look at the square root of 48 over the square root of 12. Now if you can't see how to prime factorize this easily, you can do a factor tree. And it doesn't matter how you do your factor tree, you just pick out factors. So we could have 4 and 12, they give us 48. Then look at factors of 4 to get 2 and 2, 2 times 2 is 4. Remember 4 times 12 is 48. 12 is the same as 4 times 3, and 4 is 2 times 2. So we can see that 48 will be just all these n numbers times together. 2 times 2 times 2 times 2, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 will give you 48. So we get 2 times 2 times 2 times 2 times 3 all over, and the prime factors of 12 are 2 times 2 times 3. 2 times 2 is 4, times 3 gives you 12. Now remember what we're going to do, we're going to pair these up. So there's a pair, and there's another pair. And you get the two numbers there paired up, and we split up into our pairs. If you can spot the square numbers and understand that, then feel free to speed up the process rather than using this. This is just really if you really can't spot the square numbers. So what effectively I've done is therefore this pair has become here, and the other pair has come here, and the other pair has come here. And therefore this is equal to the square root of 4, which is just 2, times this one is just 2, times square root of 3, and then we got that over 2 times square root of 3. So we can see how the top two numbers end up as that, and the bottom one ends up as that. Now I'm running room out the bottom. I normally like to, actually no, we'll stick to equals signs going below each other. I can just scroll down. And we've got the equal sign, keeping it nice and neat. So 2 times, we can see that the 2's are going to cancel. We've got factors. You've got factors top and bottom, and there's no additions in between. You can cancel out. So we've got a factor of 2, and we've got a factor of 2 we can cancel out. We've got a factor of 3, and we've got a factor of 3 we can cancel out. So the answer to this is just 2. Okay, our last little example we're going to have in this section of surds, we're going to do 5 root 3 times by 7 root 5. Now when you're multiplying, the order of the numbers doesn't matter, so let's just reorder it. So we just do 5 times 7 times root 3 times root 5. So 5 times 7 is just 35. Times by, now we can change the root 3 times root 5 to root 3 times 5, and that equals 35 times root 15.